Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we calculate the distance and midpoint of a line segment. So note that a line segment has a start and an end point, in contrast to lines which we've seen go forever in both directions. So let's first start by calculating the midpoint. So let's look at the Cartesian plane on the screen. So we have a line segment. It has a start point and an end point. So what we want to do is we want to find the value of the point that's halfway along the line segment between A and B. So we give the line segment a name according to its endpoints. This would be line segment AB. So it's probably unsurprising to you that the midpoint is a point. So if I call, in this case, the midpoint point K, doesn't matter what you call it, it needs an X value and a Y value. So it's pretty easy to figure out that the X value of the midpoint is just the average of the X value of the two endpoints of these 2 points here. So all I do is I add up the two X values and divide by 2. Similarly, to find the Y value of the midpoint, I just find the average or the middle of the two Y values. So of course, A, we have the point -1, -2, that's A. B is the point 3, 4. So the midpoint K will just be the point. So X values added up together, -1 plus 3. Remember, X is always listed first. And then divide by 2. And then the Y values listed second. You just add them up and divide by 2. So, of course, the point you get here is 1, 1. And that's intuitive from looking at our line segment. The midpoint is here, 1, 1, halfway between A and B. And you can see that it's 1, 1 there. Okay, how easy is that? So that's for midpoint. But let's say we want to find the distance. Well, this actually kind of looks, if I rub this out, like the hypotenuse of a right-angled triangle. We can make this into a right-angled triangle by going across and up. We know it's right-angled because X and Y axis are always at 90 degrees to each other. So it's sort of like when we're finding the gradient. Figure out how far you've gone across and how far you've gone up. So from X equals -1 to X equals 3, we've gone across 4. We've gone up from -2 to 4, we've gone up 6. So the run is 4 and the rise is 6. So the gradient would be 6 over 4. But to find the distance, which I'll call D, it'll just be the square root of the two shorter sides of the right-angled triangle. Shorter side squared plus shorter side squared. It's the run squared plus the rise squared. So remember, if you're asked for exact form, you just write as square root of 52 and say to 2 decimal places, it would be 7.21, okay? So that's all well and good because we had the diagram, but let's now look at an example where we don't have a diagram of the line segment and want to calculate the distance and the midpoint. So let's look at the line segment joining -3, 3 and -1, 6. We're going to calculate the midpoint and the distance. So we don't want to draw up a Cartesian plane and plot the points. That takes too long. We'll just use the formula. So remember, for midpoint, the answer's a point. We add the two X values, divide by 2. We add the two Y values and divide by 2. So the midpoint of this line, -3 plus -1 over 2, 3 plus 6 over 2, right? And of course, the answer we get is -2, 4.5. Note that the coordinates in the midpoint do not need to be whole numbers, okay? So just the average of the X values, average of the Y values. How easy is that? Now, to find the distance, remember what we did if we had a diagram was we found how far we've gone across. So that is the difference of the X values. That's one shorter side of the triangle, and the other shorter side was the difference in the Y values. So x2 minus x1 is how far we've gone across, y2 minus y1 how far we've gone up. Remember that for Pythagoras, the hypotenuse is the square root of shorter side squared plus shorter side squared. So we're just going to use that formula here. Just like when I was finding gradient, I label them x1, y1, x2, y2. So the distance here will be the square root of x2 minus x1, so it's minus 3 squared, plus y2 minus y1 squared. So if you put that on your calculator, you get the square root of 25. This will just be 5u for units, because we've gone across 4, we've gone up 3, so the distance of the line segment is square root of 3 squared plus 4 squared, which equals 5. All right, let's just look at one more example now where we're finding one of the endpoints of the line segment. So now we're told line segment AB, so that means endpoints are A and B, has a midpoint of 4, minus 1. We know one endpoint is 2, 3, and we need to find the other endpoint. So rather than drawing up a Cartesian plane and plotting points and measuring stuff, that will take too long. Let's write what we have. So we have line segment AB. So we know that A is the point 2, 3. And we know in the middle of that is 4, minus 1. So what is B going to be? Well, it's going to be a point. So because the midpoint is in the middle, 4 is in the middle of 2, the first x value, and the next x value. So we added 2 to go from A to the midpoint, so we need to add 2 again to get 6. That makes sense because 4 is in the middle of 2 and 6. We do the same for the y values. How do we get from y value of A to the y value of the midpoint? To get from 3 to minus 1, you subtract 4. So we're going to have to do that again. Subtract 4 again. Minus 4 gives you minus 5, okay? And that makes sense. We know we're right because minus 1 is halfway between 3 and 5. How easy is that? All right, thank you so much for watching this video. This has been the luckiest maths teacher in the world. Have a great day.